Hello, my darlings. So today we're going to talk about classification of matter. By the end of the video, you should be able to distinguish between elements, compounds, and mixtures, and also distinguish between homogeneous and heterogeneous mixtures. So let's get started. So what is the matter, or what is matter? Matter is anything that has mass and occupies space. That it defines it as being matter. Now, matter can be invisible to the eye, or it can be visible. It can be such as you or the computer that you're looking at right now, but it can also be the air that we're breathing. So anything that has a mass or occupies space is matter. So like we know that scientists, we love to classify things, and one of the things that we like to do is classify matter. And one way that we classify matter is by its composition. We look at matter and we say, like, what is it composed of? And then we can classify them into categories. Now, the reason why we do this is because it is the best way to do it. So think about, why is it not a good idea to classify matter by its phases? Well, think of it, because one substance can exist in more than one phase. So we're not going to just classify matter as solid, liquid, or gas, because, for instance, right here, we've got a picture where water is in 3 different phases. We have water in the liquid phase here. We have solid water here, where it's got this cool glacier. And we also have some water droplets that are dissolved in the air around us. So because matter changes phases really easily, classifying matter by phases is not really the best way to do it. Another thing that we don't use is classifying matter based on physical characteristics, such as their color. It wouldn't really help scientists, and it wouldn't be very useful if we grouped like things like gold and sunflowers and the sun together into one group, because that's the only thing they've really got in common. So it doesn't really make sense. So the way that we classify them is based on their composition. And so when we base them on the composition, we ask ourselves a few things. We ask ourselves, one, is it made up of more than one type of substance? Is the matter going to be uniform throughout? Can that matter be separated by a physical means? Or can it be separated by a chemical means? So ultimately, using these questions, we can define matter into these 3 categories. We can call them a pure substance of an element, or a compound, or it can be a mixture. So let's talk about the first pure substance, or an element. All matter, living and non-living things, are made up of atoms. And I think you guys have probably heard about atoms before. And atoms are those extremely small building blocks of matter. Those are the smallest part that cannot be broken down into smaller pieces using chemical means. They're the smallest distinct units in a sample of matter. So if you're talking about one type of matter, it can't be broken down any further than an atom without changing what it is. And each atom is made up of only one type of element. And we've talked about elements before, and we know that we can see those elements by looking at the periodic table. So all of these here are individual elements. We've got an element of lithium, we've got the element of beryllium, we've got the element of iron and nickel over here, and all of these things are individual different types of elements. And so a pure element that we're going to talk about in class, like the type of matter that we're talking about, an element, that means that it's only going to be made up of one type of atom. So for an example, if we look here at, like, let's pretend this is what the element looks like on the molecular level, super, super tiny. And we can see that these, like right here, represent, each one of these balls is representing an atom. And each of these atoms are exactly the same. So if we looked, we could say that this here is the element of solid, let's say solid iron. That would mean this is iron, this is iron, this is iron, this is iron, and this is iron. Every one of those atoms in that chunk of iron is iron. Therefore, that is going to be defined as an element. Some examples of, other examples of an element would be, here we go, we got copper wire. So we got this nice cool copper wire here that has been drawn around here. And another example is aluminum foil. If we even broke this aluminum foil down and took a super, super strong, powerful microscope and saw the atoms in between them, all of those atoms would be just aluminum, nothing but aluminum atoms, all bound together. And so that's what makes this type of matter a pure element. The second type of matter is compounds. This is where you actually take two or more of different types of elements. So if you take two of those elements, such as like two hydrogen molecules, if you look down here, and we have them bound together with an oxygen, creating a different type of matter, and that's what's creating this molecule right here. We got one molecule of water, which has two atoms of hydrogen bound to one atom of oxygen, and this right here cannot be separated by any physical means. You'd have to use some sort of chemical mean to separate this. That's what makes this a compound. So it's made up of two or more different types of elements that cannot be separated by a physical mean. Now, you can always tell if a type of matter is a compound by looking and saying and asking yourself, can it be shown by a formula such as H2O? Because we've heard that before. So if you're looking at the matter and trying to decide, well, is it a compound or is it an element, look at your element here. Is there only one type? And can you actually see that there's a formula to it? You see this big, long, cool formula, then you know that it's going to be a compound. And if you look at this in the molecular scale or molecular level, you're going to see that if you look here, that they're not going to be all the same type of atoms. You've got right here, we've got an atom of chlorine. Here we've got an atom of sodium. We've got another atom of chlorine, another sodium, and chlorine, and sodium, chlorine, sodium. You can see that this entire substance is made up of sodium and chlorine atoms. And this, my darlings, is salt. This is sodium chloride. It's composed of sodium atoms and chlorine atoms. All right, and then the third type of matter is called a mixture. This is where you literally mix them together. So it's a mixture. It's made of two or more substances, either elements or compounds, or even both, that are not chemically combined. So as we talked about here from the previous one, like this is a little water molecule right here where you can see the two hydrogens are chemically bound to the oxygen. We also in this mixture have this piece of sugar molecule. This would have a lot of carbons, a lot of hydrogens, and a lot of oxygens bound to it. And so you can see that the sugar molecule is separate from the water molecule here. And so that's what makes this a mixture, is that your water molecule and your sugar molecules are separated. They're two different compounds, and that these can be separated by a physical means. They're not bound together. So this is just an example of sugar being dissolved in water. If you look here, we can even subdivide mixtures even further. So there's two types of mixtures. You've got heterogeneous mixtures and homogeneous mixtures. And I think we've talked about this before, and I think you talked about this in language arts. Hetero and homo, the prefixes, homo meaning the same, hetero meaning opposite or different. And so that's what this is going to be. A heterogeneous mixture looks like they are composed of two different things. You can physically see that it's different. A homogeneous mixture looks like it's composed of one thing. And you don't know it until you actually go down into the molecular level here to see that they are actually composed of different ones. So to talk about those a little bit further, let's talk about heterogeneous mixture. So let's look here. This is where a mixture in which different materials can easily be seen. If you have a mixture here, such as my favorite Sour Patch Kids, right here, I can pick out the green Sour Patch Kid from the red Sour Patch Kid, from the yellow, from the orange. You can literally see that they are physically different. You can separate them out. This is an example of a heterogeneous mixture. Same thing over here for one of my second favorites, the gummy bears. You can pick out the different ones. So if you're picky, then you didn't like the green ones, but you liked all the red ones or something, then you could pick out the ones that you wanted. And so if we kind of represented this with a molecular model, you can see here where you have like the purple atoms are distinctly different than the like teal atoms right here. And some other examples of mixtures, if you think of your pizza, if you didn't like the pepperoni that was on it, you could pick that one off. Or Tex-Mex, if you're like me and I pick out all the pretzels and I eat the other stuff. or trail mix. You can easily pick them out. If you can differentiate between and physically see by your eye the different parts of a mixture, then we call this a heterogeneous mixture because there's different parts to it. Now you can contrast this with the homogeneous mixture. And a homogeneous mixture, which we also typically call a solution, it looks like there's only one type of matter there, but we actually know that it's more than one of them. So it looks the same throughout. So some examples here are my favorite, coffee. So we know that coffee, sometimes people put some sugar in their coffee, not me, but some people put some sugar in there and it dissolves it here and you can't really see the sugar crystals anymore. And so it looks like every single thing that's in that cup looks exactly the same. We know that it's not. You've got some water molecules, some sugar molecules, some of the nutrients from the coffee beans are in there. And so that's what makes this a homogeneous mixture. Homo meaning the same, so it looks the same throughout. Same thing with milk here. In milk, we know that in milk we've got a lot of calcium, it's water-based. We also have a lot of other vitamins and nutrients in there. We also have some lactose, some of that milk sugar that's in there. We've got some fat in there. All of those things are really healthy for you, but you can't really distinguish between them. You can't say, oh, I don't want that lactose right there, so I'm just going to pick all the lactose molecules out of there. You can't really do that with this, right? So that makes this a homogeneous mixture. Homo meaning the same throughout. Okay, so let's recap with what we've learned today. So we know that atoms make up all types of matter, and we know that matter can then be subdivided into either a substance or a mixture. And substances such as elements, where that big chunk of matter is made up of only one type of elements, and all those elements can be found on the periodic table. Then we also have compounds such as water, which is made up of two different types of elements of hydrogen and oxygen that is chemically bonded together that cannot be separated. Or another example is salt, where you have sodium and chloride chemically bonded together. So that type of matter is made up of two different types of elements that cannot be separated by physical means. Now contrast that with mixtures. Mixtures are where you're made up of two or more different types of matter, either two elements or compounds or an element in a compound. And those can be subdivided into either homogeneous or heterogeneous. And so right here, where it looks like they're homogeneous, where it looks like it's all made up of the same thing. But when you look at the molecular level, you can see that there's two different types of elements there. Or a heterogeneous mixture, where if you look at it, you can see that you can actually differentiate between, oh, this is one type of molecule, this is another type of molecule. Here's just another way to look at this, just another way here, just another screen I'm going to show you. So if you wanted another flow chart, you can look at here. Here's another one where if you want to look at the molecular levels and compare them, here we've got an atom of one element. So at the molecular level, just one type of atom. Here we go. We've got molecules, two bound together. Here's molecules of a compound. And then right here, we've got a mixture of elements where we've got an element here. We've got an element here of two atoms bound together, and then we've got a compound here, and those guys are all mixed together, floating around separately. All right, so now let's play What's the Matter? This is where I'll give you a picture, and you tell me the type of matter that is being shown, whether it's an element, compound, or a mixture. And sometimes I'll ask you to even tell me whether the mixture is a homogeneous or a heterogeneous one. So feel free to, as you go through here, to pause it to give yourself more time before I give the answer. All right, so let's get started. So let's start here with our first, what's the matter? So here we got rocks here. So what about the rocks? If we look at a rock here, is that going to be an element, a compound, or a mixture? All right, here we go. It is a mixture because you can see if you looked at the rock and very, very close, you can see all the different specks and the different types. of substances that make it up. All right, next one. How about this one? Copper. Here we got some copper wire. Element, compound, or mixture? Give you a few seconds. All right, let's see. Did you say it's an element? Yes, it is an element. Yes, because if you looked at the periodic table, you can see that it is made up of only copper. See, you can find it on the periodic table. All right, now let's go to the next one. How about some jelly beans? Jelly beans. Element, compound, or mixture? Let's see. Did you say mixture? Yes, it is a mixture. And then here, bonus points for you. Is it a homogeneous or a heterogeneous mixture? Did you say heterogeneous? Yes, you did. I know you did. Yes, it is a heterogeneous mixture because if you're like me, you can pick out all the black ones here. I don't like the licorice ones, and I don't really like the orange ones. Yeah, I like the red ones. All right. So, next one. How about table sugar? Element, compound, or mixture? Ooh. Let me give you a hint. You can actually see that the formula for table sugar is C6H12O6. Does that help you? Did you say that this is a compound? Yes, you did. Yes, you did. I know you did. Excellent. All right. How about this? Diamond. Element, compound, or mixture? I'll give you a hint here. Diamonds are compressed carbon under a lot of intense heat and pressure. Did you say that it was an element? Yes, you did. I know you did. Yes, it is an element. All right, how about this one? Tea, a nice cute cup and a full tea. So what would that tea be? Element, compound, or mixture? Did you say mixture? Then you are correct. It is a mixture. All right, now here's bonus points. Heterogeneous or homogeneous? Ooh, does it look the same throughout or does it look different? If you said it was homogeneous, you are correct. Homogeneous. All right, how about this one? Salt. We kind of talked about this before. Salt. It can be represented by the formula NaCl, sodium chloride. Did you say that it was a compound? That is correct. It is a compound. All right. How about this one? Neon gas. That gas is flowing through here to make those neon signs. It can be represented with the chemical or the element Ne. Oh, I think I just gave that away. Element. Yes, element. All right, let's go to the next one. Ooh, this looks yummy. How about salad? Salad. Element, compound, or mixture? Did you say mixture? You are correct. Follow up. Heterogeneous or homogeneous? Did you say heterogeneous? That is correct. All right, let's do another one here. Let's do a nice, delicious aluminum can here full of delicious soda pop. Aluminum represented with the formula Al. It is on the periodic table of elements because it is an element. All right, here's a hard one. Lemonade. Lemonade. Yum. Look at all I'm showing you food and beverages. Huh, I need a snack now. Okay, element, compound, or mixture? Mixture, right. It's got a lot of nice, cool lemon juice. You got to add some sugar and some water in there. Good. All right, so let's do one more. How about sand? Sand. Element, compound, or mixture? Did you say mixture? Yes, I bet you did. Yes, it is a mixture. So is that heterogeneous or homogeneous? And look, I've zoomed in here for you. So if you zoom in on sand, Heterogeneous or homogeneous? Look at all these cool particles here of different shells. Look at that one. If you've ever been like me on the beach, you take home some cool particles here. Yes? So if you can pick out all of those cool particles, then it must be a heterogeneous mixture. All right, so how did you do? I'm sure you did wonderful. All right, thanks for watching. Bye.